Okay, so now we're on to applications of derivatives. So we'll start with number 1. On the interval 1 to 3, what is the average rate of change of the function? It's if s is 3t squared minus 4t. So we see average rate of change. So we know that we're looking for that with a slope. And whenever you see an interval, that's kind of a key. It's a hint that you're not going to take the interval or the derivative. I'm sorry, right away. You're going to strictly use the function and just find the slope from 1 to 3. So we're going to use this, s of 3 minus s of 1, oops, 1, all over 3 minus 1. And this is just like the slope formula, y2 minus y1 over x2 minus x1. So we just evaluate s at 3 and s at 1. So s at 3, 3 squared is 9, 9 times 3 is 27, minus 12 is 15, minus s at 1 is going to be negative 1, all over 2. So we get 16 over 2 for 8. So average rate of change, it's just slope. Find the equation of the line tangent to the circle, x squared plus y squared equals 25 at the points 4, 3. Okay, so we're going to take the first derivative. That's how we're going to get our slope of the tangent line. So we're going to say 2x plus 2y dy dx equals 0. And we've got dy dx. Let's do this. 2y dy dx equals negative 2x. Okay? Now we divide both sides by 2y. So dy dx equals negative 2x over 2y. The 2 divided by 2 is 1, so we're left with negative x over y. Okay? So we don't have a slope yet. We have a derivative, right? So we're going to plug in our x and our y value. All right, so we have negative 4/3. So the m tan slope of the tangent line is negative x over y, so negative 4 divided by 3. Okay, so let's just look at our answer choices. And if we use the point slope formula, we get y minus the y value, x minus the x value. So here's a negative 4/3, x minus the x value, y minus the y value that we're given in the problem. And that looks like the only slope with negative 4/3, so that would be it. I'll clear the annotations and scroll down. Number 3, x-coordinate for each point of inflection. We see points of inflection, and we see we're given f prime. So we're not taking two derivatives. We're already at f prime. We're going to do one more derivative. So f double prime is 3x squared minus 6x. And that looks like it. So I want to set this equal to 0 to find the points of inflection. I'm going to factor first. Take a 3x out. And then, so 3x, x equals 0. And x minus 2 equals 0. So the value that makes this 0, x would be 0 here. And then the value that makes this 0 would be 2. So our values are 0 and 2. A projectile fired upward. Distance above the ground is given by that formula. At what time in seconds does the projectile achieve its maximum height? So first of all, we got to figure out where the first derivative is 0, because we know that when it's actually s prime. So s prime of t equals 0. There's a min or max. Okay, and so since it's a squared function, our derivative is going to be linear, so there's only going to be one value. and we'll find that, and then we're going to need to go back and plug it back in the problem to find out what is, oh no, it says what time, I'm sorry. So it is, we can just leave it at that. Once we find our t value, that's it. So s prime of t equals 112 minus 32 t. So we set this equal to 0. Add 32t to both sides, we get 32t equals 112. T equals 112 over 32. And wow, a quick reduction. If we go by 2 first, we'll get alright, sorry for the delay. And so it looks like both of these can reduce by 16. I was trying to just go through my head, start with 2, 4, then 8, what they'd be divisible by. And they're both divisible by 16. So 112 divided by 16 is 7. 32 divided by 16 is 2. So our maximum, we know it's a maximum, and we don't have to go check the second derivative for concavity, because when we see this, we should know that shape is going to be the upside down U, like this, and it has a max. Alright, so 7 halves. Alright, let's clear the annotations and move on. So number 5. Which of the following is the graph of the 6th derivative of the function f of x equals what's given there? Alright, so the 6th derivative. If we look at our function, the highest power is to the 5th. So every time we take a derivative, that exponent is going to go down 1. So for the first derivative, it'll be a 4th. So, and I'm going to keep track of it here. So f prime x is, I'm going to put dot, dot, dot. I don't need to write all that stuff. And the reason is, okay, dot, 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 f triple prime, okay, dot, 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 f quadruple prime. I'll just abbreviate it there. 120x dot, 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 f the 5th derivative 120, and the 6th derivative, we know the derivative of a constant is 0. So the 6th derivative is 0 for every x. So which one of those lines is the y value 0, or, well, it's close enough to 0 so you can actually see the line. But anyways, it's C. So all values here are going to be 0 for any x. Alright, so that's the 6th derivative. Alright, and we got time. Let's do number 6. So, calculator allowed. Well, I don't have the calculator page up, so I'll do that on the next set. I'll bring the Inspire up. Okay, so these ones are done for 1 through 5.